The mathematical explanation behind interference is quite simple. Let us assume that we have two monochromatic waves, waves of the same color, of the same frequency, that can interact with each other, and each of them can be represented by its amplitude u1 absolute value and its phase phi1. Then the second wave u2 can be represented by its amplitude u2 absolute value and its phase phi2. If we want to record these waves, we can use a digital camera, but the camera is sensitive to intensity only, which means that as soon this complex wave hits the camera makes absolute value square on this entire complex value, meaning that u1, which has an amplitude and a phase, will turn into u1 amplitude value square, as you can see here on the left, which means that the phase information is lost. The same thing is for I2, the intensity that is created by the second wave. I2 equals u2 absolute value square. What happens if we want to record the intensity of the superposition between the waves? u1 plus u2 absolute value square is equal, because each of them is a complex number, is equal to u1 absolute value square plus u2 absolute value square plus the cross term u1 multiplied by u2 conjugate plus u2 multiplied by u1 conjugate. That means that we didn't get a summation of the intensity. The total intensity I is not equal to the intensity of each of the waves, I1 plus I2, because these two waves interact with each other. This is the interference phenomena. This cosine pattern is the interference. Here you can see a visualization of this interference. You get I1 plus I2, which is a bias here, and a cosine all over this graph. This cosine is actually the interference between the waves that captures their multiplication of the amplitudes and the phase information or the phase difference between the wave, phi2 minus phi1. We will obtain this cosine term only if the light is coherent enough, or in other words, the beams creating the interference u1 plus u2 are coherent to each other. This interference is very hard to obtain in white light, which is a non-coherent light. In order to obtain this term, these two waves has to be coherent to each other.